Hi, in this problem, I'm going to solve a square root equation where we have one extraneous solution and one real solution. I'm also going to show you how this equation is solved on a graphing calculator. So let me go ahead and rewrite the equation of the square root of 2 minus 2x equals x plus 3. First thing you want to do is get rid of the square root symbol. To get rid of the square root, I'm going to square both sides. But because I'm squaring the left side, I need to square the right side. I need to square all of the expression x plus 3. Now, the square root and the square cancel, and we are left with 2 minus 2x is equal to x plus 3 squared. So I'm just going to go ahead and write x plus 3 twice. On the right side, I'm going to go ahead and distribute x plus 3 times x plus 3. So we end up with x squared plus 3x. And I'm going to distribute 3 times x here, that's 3x, and 3 times 3 here is 9. I always like drawing a little fish once I have squared. I don't know why, just one little thing I like to do. All right, then I'm going to go ahead and rewrite the left side, and we are going to combine like terms. So on the right side here, and I'm going to combine plus 3x and plus 3x. So we are left with 2 minus 2x is equal to x squared plus 6x plus 9. Anytime you are given a quadratic equation, which is what we have right now, what you want to do is always put your equation in standard form. Once we have our equation in standard form, we can then solve for x either using the quadratic formula or if we can, we factor. So I'm going to go ahead and solve for both sides. I'm going to bring everything from the left to the right. So I'm going to subtract 2 here and therefore subtract 2 from the right side. I'm going to also add 2x. I'm doing 2 steps in one, and therefore I'm going to add 2x here on the right. What I basically did is I just put the like terms together already. Now on the left, if you guess that we are left with 0, you are right. This will be 0 on the left, and combining like terms on the right, we end up with x squared plus 8x plus 7. All right, once we have our equation in standard form, then we look to see if we can factor it. If you can't factor it, you should use the quadratic formula. But I can see that this does look factorable. What you're looking for is two numbers that give you 7 when you multiply that add up to 8. So if you said 7 and 1, you are correct. 7 times 1 gives us 7, and 7 plus 1 is 8. So I can go ahead and factor this as x plus 7 times x plus 1. Once you have your equation in factored form, what you want to do is use the zero product property and solve for x. So I'm going to go ahead and use the zero product property. Zero product property means that we're going to set x plus 7 equals to 0 and x plus 1 equals to 0. And solving for x on both, I get negative 7. So x equals to negative 7. X plus 1, we're going to subtract 1 on both sides. X plus 1 equals 0. So we get x equals to negative 1. Now we do not say these are solutions yet until we have checked for extraneous solutions. What does that mean, extraneous solution, right here? As I mentioned in my previous video, extraneous solution occurs when you have a square root that when you plug your solution, in other words, either negative 7 in this case or negative 1, we end up with a negative inside the square root. So that is not going to be a real solution, and we are looking only for real solutions. Another option is even if everything is positive in your square root, after you simplify, you end up with a negative on the right side of the equation. So therefore, that is not going to be a real solution either. So let's go ahead and check x equals negative 7. And I'm going to input it into this equation. So we end up with 2 minus 2 times negative 7 is equal to negative 7 plus 3. When I simplify the left, you could see that this will end up up being a positive because negative 2 times negative 7 is 14 and 2 is 16. So you want to simplify this part first. Negative 2 times negative 7 is 14 plus 2 is 16. So the square root of 16 is okay, but the problem arises right here when we have negative 7 plus 3, we end up with a negative 4. Now when we are taking the square root, when we're solving our real solution, we are only looking for the positive of square root of 16. So therefore, negative 7 is not going to be a real solution. So we're going to call this extraneous. Negative 7 is called an extraneous solution. All right, let's go ahead and check negative 1. Plugging in x equals negative 1 to our original equation, we end up with 2 minus 2 times negative 1, which equals to negative 1 plus 3. When we simplify on the left side, negative 2 times negative 1 right here, this results in positive 2, and positive 2 plus 2 is 4. So we end up with 4 square root of 4 is equal to negative 1 plus 3, which is 2. So this is correct. So our only solution, therefore, is x equals to negative 1, and x equals to negative 7 is our extraneous solution. So we never use an extraneous solution as part of our solution. So therefore, you will only say that we have one solution, and that is that x equals to negative 1. Now, I like to show this on a graph, so I'm going to go ahead and I'm going to graph the left side, and I'm also going to graph the right side. And that means where they intersect is our solution. So let's go ahead and see that. All right, graphing the equation on the left, what we have is we have the square root of 2 minus 2x. So that is our square root function right here. And on the right side, we have x plus 3. So you can see that our solution is at negative 1. When x is negative 1, y is 2, which is exactly what we got when we solved. We got that negative 1 was our solution. And you could see that the graph does not intersect at x equals negative 7, which would be somewhere here. So this is how you would solve for a square root function with an extraneous solution.